Hi, welcome to Meg Watson. Today I'm going to talk about the 10 technical questions that you must know if you're interviewing for power system operations related jobs. So let's get started. Question number 1. What is AC power flow? The objective of an AC power flow is to determine the voltage and current levels at each bus in a power system and calculate the active and reactive power flow in each transmission line or transformer under a given set of operating conditions, such as load and generation levels, as well as network topology. Question number 2. What are the typical bus types in a power flow analysis? Typically, there are 3 types of buses in a power flow analysis. There are PQ bus, PV bus, and slack or swing bus. For PQ bus, the real and reactive power drawn from the bus are specified or known. These buses usually represent the load in the system. The voltage magnitude and angle at these buses are solved during the power flow analysis. For PV bus, the real power output and the voltage magnitude at the bus are specified or known. These buses usually represent the generators in the system. The reactive power output and angle at the bus are solved during the power flow analysis. For slack and swing bus, this is the bus at which the system's real and reactive power balance is maintained, and the voltage magnitude and angles are fixed. Question number 3. What are the critical inputs to solve a power flow problem? You need the following information to solve a power flow problem. First, you need the real and reactive power drawn from each PQ bus. Then you need the real power output and voltage magnitude at each PV bus. You also need the voltage magnitude and angle at the slack or swing bus. In addition, you need the series reactor R, reactance X, and the charging susceptance B of each transmission line. And finally, you need the network topology so that you know the connection in the grid. Question number 4. What is the surge impedance loading of a transmission line? Surge impedance loading, or SIL, is the amount of real power that makes a transmission line act like a resistor. That is, the net reactive power injection or consumption of that transmission line is 0. When the active power flowing the line is less than its SIL, the line produces reactive power. When the active power flowing the line is greater than its SIL, the line consumes reactive power. Question number 5. What can you do to correct a low voltage problem in real-time system operations? There are various actions that you can take to correct a low voltage problem. You can switch in any shunt capacitors that has not been switched in, or you can switch out any shunt reactor if they are already in service. You can also stop pumping. You can also turn on a generator in a low voltage area. Typically, a generator will help the voltage profile. You can also choose to increase the terminal voltage set point of generators in the low voltage area. Or you can switch in series capacitors on the line. If possible, you can also return and outage the transmission line. Finally, and this is usually used as the last resort, you can do some load management, for example, shed firm load. Question number 6. What can you do to correct a high voltage problem in real-time system operations? You can pretty much take all the actions in question number 5 and reverse them, and you will get the correct answer for this question. You can switch out shunt capacitors if they're in service. You can switch in any shunt reactors if they're not in service yet. You can start pumping hydro or start charging batteries because they're essentially behaving like a load. You can turn off generators in the high voltage area. You can also decrease the terminal voltage set point of generators in the high voltage area. You can switch out series capacitors on the line. or you can switch out lightly loaded transmission line if applicable, and make sure you study this first. Question number 7. What is the difference between phase voltage and the line voltage? What is the relationship between a phase voltage and line voltage in a balanced three-phase system? Line voltage is the voltage between two phases, for example, phase A and phase B, or phase B and phase C. Whereas the phase voltage is the voltage between the given phase and neutral. In a balanced three-phase system, the line voltage is square root 3 times of the phase voltage. Question number 8. What is area control error, or ACE? Area control error, or ACE, is the difference between the scheduled and actual interchange in megawatt, taking into consideration the frequency bias and meter error contributions. Holding the frequency component constant, ACE indicate whether the generation and load in the system are balanced. Question number 9. What is power factor? In power systems, the power factor is the ratio of the real power and the apparent power drawn by the load at a specific bus. Power factor can range from 0 to 1. A power factor of 0 means no active power component, whereas a 1 power factor means no reactive power component. The higher the power factor is, the more efficient of the transmission system is utilized, as it is usually better to compensate the reactive power locally. Question number 10. Why do 3 protection zones overlap? Well, the main reason for overlapping protection zones is to provide redundancy, so that lower priority relays can back up the higher priority ones in case they fail to operate. For example, if the primary Zone 1 relay fails to detect and clear a fault, then Zone 2 relays will kick in with a delay and clear the fault. Alright, that's it for today. I hope you enjoyed the video, and if you do, please hit the like button and subscribe to my channel. See you in the next video. Bye.